is. And a sequence is a pattern of numbers. So somebody give me an example of a pattern of numbers.
1, 2, 3.
1, 2, 3. What was that pattern? What happened to the numbers each time? It added 1 each time. Yep. That's an example. We have what we call a finite sequence and an infinite sequence. Does anybody know the difference in those two words?
Well, there's no IN in finite.
That is true. There is no IN in. Well, actually, there is an IN in finite, but finite does not begin with the IN. Does anybody know what infinite means?
It goes on forever.
It goes on forever. So finite is the opposite of that. It has an ending point. So a finite sequence, I don't know why we don't call it finite. We have infinite and finite. Sequence, it's a sequence, so a pattern of numbers that has an end. So for example, we might have 5, 7, 9, 11, 13, and that might be it. That is my pattern of numbers, and it stops. An infinite sequence is a sequence that goes on forever. Now, obviously, we cannot continue writing forever and ever. We literally sit here until we die. How do I show that a pattern of numbers goes on forever? Anybody know? Dot. Yep. So if I have 2, 4, 8, 16, 32, that means it goes on forever. What was my pattern here?
It doubles every time.
It doubles, yep. So within a sequence, each number is called a term. This is a term. Each term, I use T for term, not term 1, term 2. We use an A. So when you see an A with a little number, that means it's a term, and this one will be the first term. If I had A with a little 2, so I would say A sub 2, because the 2 is a subscript. So this is A sub 1, or A1, term 1. A10 would be the 10th number in my pattern, or the 10th number in my sequence. Now, in general, we use AN, where N is the term number in the sequence. So, sometimes we'll say it will just be general, AN. I'm just talking about one of the terms. Okay. So, let's look at this example right here. 1, 5, 9, 13, 17. What's happening each time? It's adding 4 each time. Yep. So it's plus 4. I want to know what A1 is. What is my first term? 1. Good. What about A4? 13. This is term 1, term 2, 3, 4, 5. That ... means it goes on forever. So, can I figure out what A10 and A13 are?
Yeah.
Yeah, I just keep this pattern going. So, I have 5 right now. What would be my next one?
21.
21. Good. Then what? Good. Somebody else?
29.
Good. Somebody else?
33.
33. Thank you. So, all right. So keep going. What's after 33?
37.
37. Next.
41.
Next.
45.
Next.
49.
Okay, let's see. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my 10th term is 37. 11, 12, 13. A13 or A sub 13 is 49. Now if I ask for A 125, that's going to be hard to figure out like this. So I'm going to show you later on how we would find those terms way down the line. So you don't have to keep going plus 4, plus 4, plus 4, plus 4. But for right now, we're going to find the next 3 terms in the sequence. So I'm given -1, -2, -4, -8, -16. What's happening?
They're doubling.
Doubling, multiplying by 2. So -16 times 2 is what? -32 times 2 is?
64.
Yep, times 2?
-128.
Yes, -128. Number 2, 3, 6, 11, 18, 27. What's happening here?
It's increasing by 5.
3 plus 5 is 6?
Wait, no.
How do I get from 3 to 6?
Add 3.
Plus 3, what's this one? Plus 5 plus
7.
good plus 9. So then I need to do plus 11, which would be 38. Then I'm going to add what? 13. And what is 38 plus 13?
51.
51. And then I'm going to add what?
15.
15. Good. 66. Now number 2, this one is adding just 5 every time. Plus 5, plus 5, plus 5, plus 5. So if I do 5 more, I'm going to be at 56. Plus 5 is 61. Plus 5 is 66. Any questions? So an explicit formula is a formula that helps find any term in a sequence. So instead of just having to go plus 4, plus 4, plus 4, plus 4, plus 4 100 times, if I am given a formula, I can just plug that number in. So for example, on number 4, I'm given a formula. So this AN means any term. Any term in this sequence I can find by plugging into this formula. And N is going to represent that number of term. So if it tells me to find A3, then I'm looking for the third term. And I'm going to plug in a 3 for N. So A3, 7, And then I have a 3 plus 3. So what is the third term? What is 7 times 6? 42. Good. So the third term is 42. What if I said find the 12th term? What would you do?
Replace the 3 with 12.
Put a 12 in for n. Yep, good. So number 5, I'm finding A1, which is the first term. So A1 that would be 2 to the second power, which is 4. And then number 6, I'm finding the 7th term. So negative 4 times 7 squared. And what is that?
Negative 196.
Yep, negative 196. Good. These last 3, I'm giving you the formula and I'm giving you the actual term. You're telling me which term that is. So like it would be if I had given you 42, you have to tell me 3. So if I know that AN equals 2x plus 4, and I've told you that AN equals 20, we're going to substitute the 20 for the AN because they're equal. So I'll do 20 equals 2x plus 4, and then solve. And really, that should have been 2n plus 4. I just now realized that. So that should be an n. So 16 equals 2n. So 8 equals n. So the 8th term, so if I were to list out all of the terms, I could plug in a 1, plug in a 2, plug in a 3. The 8th one would be 20. So then this one would be 45 equals 5 n minus 3. You can solve this one 2 different ways. You could distribute the 5 to begin with, or you could just go ahead and divide both sides by 5. It doesn't really matter. Most people probably would go ahead and distribute. So that's what I'm going to do. And we get 12. So the 12th term is 45. And then number 9 would be 26 equals n squared plus 1. 25 equals n squared. How do I get just the n?
Square root.
Square root. So the square root of 25 is 5. So the 5th term is 26. And that is all. So